Oh, you go, yeah. Slope is rise over run. So therefore, rise, we minus the y's, it rhymes. 7 minus -9. Run, -2 minus -5. Double negatives make positives. The only correct answer, no partial credit, is 16/3. So if they flipped it and put 3/16, right, rise, and put y minus y over x minus x to remind them that the y's go on top, please.
But they reduced it.
You can't reduce that. I mean, did they make it into a mixed fraction? Is that what you're saying?
No, I messed up. Don't worry about it.
Well, thanks for trying here, okay?
Wait, is it 16/3 or 3/16?
16/3. Okay, so some of you got stuck here. Guys, what have we been doing for 2 weeks? Almost nothing but proportions. Absolutely nothing but proportions. So to solve for the unknown, it's unknown over 6 equals 21 over, well, you don't have anything there, so you just add 21 over 14. Now, there's more than one way to do this. You also could have gone x over 21 equals 6 over 14. Cross multiply. You end up with 14 times x equals 21 times 6. Rather than multiply that out, I'm going to factor without a calculator. This is faster. So it's x, 3 times 7, and 3 times 2, 2 times 7 here. Say goodbye to the 7s, goodbye to the 2. X equals 9. The unknown is 9. That's 12. Now, they had to check. So if they have the 9 here, there's a couple ways to check. They could have gone 12 over 9 equals 8 over 6. That's one way to check, both which is a 4-to-3 ratio. Okay, well, there's more. I told you there's more than one way. Or they could have gone 21 over 9 equals 14 over 6, cross multiply, and check. But there must be some sort of check. What's worth credit? +1 for the work, +2 for the answer, +1 for the check. 4 points there. The answer is 9 because of this proportion. Okay, over here, we have an unknown here. The unknown is 6 because 16 minus 10. So I'm going to go 6 over 15 equals, 16 over unknown. Again, cross multiply, 6x equals 15 times 16. Rather than actually multiply, I'm going to factor. 3 times 5, 2 times 8, 2 times 3. Goodbye 2s, goodbye 3s. X equals 40. Then they plug it in, and you should see a check there. What's worth points? 1 point for this, 2 points for this, 1 point for some sort of check. At the bottom, it's 4 and 4. Top is 2, so it's 8 and 2. All right, guys, score and return. Score and return. Good job, Brandon. Get out your cell phones and planners, please. Cell phones and planners.
I really didn't need it.
Students, would you be interested in the largest chunk of extra credit I have yet to offer this semester?
Yes.
All right, I'm going to put this in the back in just a moment. I'll explain what this is towards the end of class, but you're going to pick it up if you choose to. Okay, I'll give you a heads up. It involves watching and responding to a certain video. It takes about 90 minutes to 2 hours to take. So this is not, okay? But it's not due for 2.5 weeks, so don't go back to your parents and say, wait, they told us over Thanksgiving. No, I did not. I'm just giving it to you now. Because some of you might be, really bored, and you don't want to talk to, grandma, whatever, anymore, and you just need a break, so you can say you have geometry homework. Although you don't, really. Okay? So, I'm going to put this in the back, pick it up, and I'll give you a due date on this in a moment. Oh, what's it worth? It's worth 50, 50. Alex points.
Yeah, I need those. I need those.
No, I'm not sure. What is the correction back?
All right, planners and cell phones, guys. Planners and cell phones. Let's get some due dates in here. Planners and cell phones.
I'm definitely doing this.
All right, this is due. The extra credit. Let's talk extra credit first, because I know that's what you're most interested in. This is due December the 6th, 12/6. That's a Tuesday. Can someone double check? I'm pretty sure it's a Tuesday. Not quite. It's not quite during finals week. Is it 12/6? Thank you, Kyle. All right, I want this in your paper, cell phone, and planners, please. Planners or cell phones, one or the other. This is not meant to be easy peasy. It will take you up to 2 hours to complete. Okay, I recommend once you queue up this particular video, put it on closed caption, even though you may not use things in closed caption normally, simply because it's easier to follow and it's easier to fill in blanks. Okay, also pre-read all questions. Okay, so next thing that you should be putting in your planners and or cell phones is take a look at your study guide. This study guide, put your name on it. It is due Friday. 12, no, of course not. 12/2, it's okay, I know. It's all right, you know what, guys? We all have a bad case of turkey brain right now, and I get that, all right? It's just, you're like craving turkey, ready for a vacation. All right. Luckily, I've had not to do that. There will be an online tutoring session Tuesday, 11/29. Guys, chill. Yeah, that's what I mean by bad case. You guys, I say one thing, you all explode into talking, okay? She'll live. There'll be plenty of other things to eat besides turkey. 11/29, 7:30 to 9 p.m. Online, I'll send you the link. That's next Tuesday. We'll also have an average of about 20 minutes per class session when you get back to work on this. And then, of course, I'm available open second, lunch and after school. You guys already know that. Friday, 12/2 is the same day as your next test and your last test of this semester. Besides the final, obviously.
Wow. Wait, we have a final?
Lucas, it's that class, it's definitely.
Yes.
Definitely during the final.
It's okay. I've got a vacation brain too. I was up way too late doing this last night.
Any cool plans for you this week?
I get to be one of the idiots flying by air on this one. Yes.
Where are you going?
My dad lives in San Diego. So, yes. Anybody else flying out on Wednesday? No other airplanes? It's the worst traveling day of the entire year. Yes. Huh? You've never been? Yeah. Oh, lucky dog. Yes.
There you go. I was 20 times.
Yeah.
If I see, I'll relax.
No big deal.
I want to go. Oh, it's alright. Okay, let's go.
That's no big deal.
Wait, where?
All right, guys, we're in session. 5, 4, 3, 2, 1. Okay, I'll give you a big heads up. The brain Java was probably about the hardest mathematical thing we've done, and we will do today.
And I got a 10.
Everything fabulous. Everything today. Listen up, guys. The rest of today is a little bit more of kind of a funsy and exploration kind of a thing. You'll be done before the bell, and you will have no additional homework. No video notes, no Alex quiz. If you choose to work on the study guide, don't tell your parents to give it to as homework, because technically you could work on it when you come back. Okay, so it's up to you. But let me tell you a quick little personal story. What's that? You're welcome. Your age. I won't tell you how long ago I was your age. That would not be polite. But I want to tell you a quick little story. It's not important. I don't deviate very often.
So what if you're like a size 16?
Hey, story time. Hey, shut up. Story time. I want to hear the story.
So, I'm probably, I think, yeah, about your age, 15-ish. Okay, so younger, a little bit older than whatever you're at. Yeah, right on top. I went through fabulous. I did not have the privilege of going to a private school growing up. I was at Andrew Hill, down the way, and college, San Jose State. And I became a believer around 13 years old. So I was not necessarily raised in a Christian family. And so it was more my decision and my understanding, and obviously God chasing me down. It's always God who starts that process first, not us. So I'm in my science class, biology, and we're just about to start the chapter that's called Origins, which you guys probably know is code for revolution. And keep in mind that obviously I'm a mathy person, which usually mathy person, you're also a sciencey person. So I love science. I love investigating things. And I consider myself a very logical, kind of reasonable person. And here I am. The teacher stands up, and no joke, this is his first sentence in the start of this chapter. He says, I don't care what you believe about origin. So I'm thinking, oh, good, I'm not going to get persecuted. This is what I'm thinking. But all scientific people believe evolution is true. But you understand what that implies? Okay, it means if you have any issues with evolution, you're therefore, take the converse of that. Actually, it's a contrapositive. Remember I told you the contrapositive is true if the premise is true? If you're a scientific person, then you believe in evolution. The contrapositive is if you don't believe in evolution, then you're not a scientific person. And that, I heard that, and that bothered me. That was like, wait a minute, because I'm a scientific person, I'm reasonable, I'm logical, I like to investigate things, and you just told me basically I'm stupid. That's what the teacher said. Okay, so it sent me on about 2 to 3 year investigation. I like to know what's true, and when evidence is presented before me, I like to investigate it. So it sent me on a journey that took about 2 or 3 years for me to really nail down what I personally believed about the concept of origin. Okay, I am not here to dictate what you do or do not believe. What I'm going to do is take you through a short exploration in the next 45 minutes of how math permeates what you see in the natural world. Okay, and I mean permeates in a way you've probably never seen before. And the bottom line is this. At the end of today's lesson, you need to ask yourself this question when you walk out. I'm not going to dictate the answer to you, unlike my biology teacher basically told us what to believe, if we wanted to be scientific people. But I'm going to ask you to think. Because bottom line, after today's lesson, when you walk out of here, you have to be able to relegate one of two conclusions. If everything you see and everything we experience in the next 45 minutes is here by chance, which is essentially the premise of evolution, or here by design. By chance or by design. I'm not even seeing evolution creation. That's just the bottom line. It's either here by random chance or it's here by design. And that's for you as students to resolve. I'm not going to dictate for you to think. but I am going to make you walk through some rational steps in the next 45 minutes. On this page, please, we're going to do a quick, and trust me, the math is easy. It's the easiest math you've done the entire year. Don't panic. Ready? Put a 1 there and put a 1 there. We're at the top of the grid. Okay, ready? 1 plus 1 is? 2. Yeah, that's how hard that gets. Put a 2 there. Ready? 1 plus 2 is? 3. 3. Good. I'm glad someone's paying attention. All right. 2 plus 3 is? 5. Fabulous. No, she's having fun. Why not? 3 plus 5 is? 8. High five. Someone's just checking in now. Someone tell her 5. Okay. Okay. And where did we leave off on? 3 plus 5, 8. Oh, bring the 8 up here. That's where I left off on. 8. Okay. 5 plus 8 is? 13. Bring the 13 up. And let's do 13 plus 8 is? 21. Bring the 21 up. We'll stop here. 13 plus 21? 34. Bring the 34 up here. Okay, now what I'd like you to do, I'd like you to get your calculators, please, if you have them.
Aaron has one.
I have one.
Sarah has one.
Okay, those of you with calculators, I'd like you to take 5 and divide by 3. Take it to the second decimal place. Give me the answer. What's that, Zach?
Hi, Zach. Mr. Ely loves you. Zach, you too.
Ready? 1 point what, guys? Okay, 1.66 repeating. Quickly. 8 divided by 5, please. Take it to the second decimal place. Go. 1.6 exactly. Okay. 13 divided by 8, please.
1.62.
Yes, 1.62. 21 divided by 13. 34 divided by 21.
1.6.
34 divided by 21. Okay. Now, if you guys look very carefully. These are all roughly the same. Roughly, obviously, there's slight variations. We learned similarity, congruent angles, ratios, equal. Now, what I'm going to do is take this pattern and we're going to make a math out of it. So, starting about, go about halfway down your grid and go slightly to the right, please. Slightly to the right, you're going to put a dot there. Halfway down your grid, slightly to the right. I'm going to start about right here. Just a dot. Okay, let's look. Our first two numbers are 1 by 1. So maybe like this really big. You're going to draw a 1 by 1, a box. It's 1 by 1. 1 by 1. Okay. Then your next numbers is 1 by 2. 1 by 2. So right here, I'm going to take the 1 here, I'm going to stretch it out by 2. That is a 1 by 2. So we went 1 by 1, then 1 by 2. Next one's going to be 2 by 3. Okay, so I'm going to change colors here. We have the 2. Now we're going to go down 3. 2 by 3. Okay, the next one is a 3 by 5. So here's 3, and then we go 1, 2, 3, 4, and 5. No. This is a 3 by 5. Next one. 5 by what? What's the next series? 8. So this is 5. Go this way. Now we're going to go up 8. 1, 2, 3, 4, 5, 6, 7, 8. This is 8. Okay, next one's 8 by 13. So here's 8. Now count 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13.
Oh, yeah. This is a huge bomb.
Okay. 8 by 13. We're going to do 2 more. If you go over the edge slightly, we'll live. If you have at least the first 6, you'll get the idea here. Then it's 13 by 21. So here's 13, and I'm going to go down 21. 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. That's the 13 by 21. And the last one is 21 by what?
34.
34. So
Goodness.
21, and start counting by 34. 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 6, 27, 28, 29, 30, 31, 32, 33, 34. Alrighty, guys. Here's 34.
You're not going to do more bigger, right?
No, that's as far as we're going. Okay, now, if you are an artsy student, this is going to be easy for you. For the rest of us non-artsy, this is going to be a little bit of a trick, but work with us here. Start at the 1 by 1, and you see these 2 opposite corners? See the 2 opposite corners? I want you to connect them with a nice, smooth curve. Connect them with a curve. I'll do this, that kind of a curve. Curve. Connected with a curve. Now, from here to here, connect with a curve.
Oh, it's far that.
Now, from here to this opposite corner, connect with a curve. Okay, I'll do this in yellow. Connect corner to corner, curve, curve, curve. Okay? Ready? From here to here, connect with a curve.
Is it a heart? Oh, no.
Connect from here to here with a curve. Oh, okay. All right. Okay. Ready? And now connect with a curve.
He's not a snail. Oh my God.
Okay, from here to here, connect with a curve.
You look like a snail. It's just a snail. It's a really long tongue.
Connect from here to here.
Looks like Tarzan plays like
It's a shell.
Okay, well, let's see what it is.
It's a shell.
it's not turkey. It's just a shell. It's just
All right. I noticed a lot of you're boarding out like real life things. It looks like this. It looks like that. It looks like a shell. It looks like a swirl.
You turn it upside down. It's definitely a squirrel. You turn it upside down.
You could, if those of you who surf, will want that look like a
A wave.
Now, I want to point something out to you. This is 100% pure math. Notice, the minute we started drawing it, you guys immediately started blurting out things in nature.
Yeah.
There's a reason why, guys. In nature has this math behind it. I'm going to show you a video in about 25 minutes. You're going to be paying attention, and the premise of this video is how math and nature are connected. Turn the page, please. We're going to come back to this. Turn the page, pages 3 and 4. No, I'm all out. I'll be shopping over the.
Shopping over Thanksgiving break.
Yes.
You can buy a bunch of.
I want you to quickly skim through all of these blanks.
Are we even doing
Yes, guys, this is your 10 points today. Just this.
this? Only this.
Yeah, well, we're going to be filling it out watching videos. Okay? What? No, that's it. This is it. This is as hard as it gets today. All right, students. Caitlin, can you skim, please? Quickly, guys, read through all of these. Read through these. You're not going to be able to catch all of these. You'll get marked out. This is your 10 points today. Ready? Skim through and read all 14 questions while I cue up the video.
I really have trouble. La la. Is that a basketball?
Yeah, we're good.
What? Your brother doesn't have school today? Elementary? Yeah.
Okay, guys, pay attention. This video is about 25 minutes. You're filling in blanks. This is what's worth 10 points today. Yes, you do. They do go in order. I will not tell you the answers. If you don't pay attention, you miss it tough. So pay attention. Did you skim through the questions, 1 through 14?
Yes, I had no idea.
3 and 4.
Consider this before doing patterns.
Thank you, Caitlin. Oh, like a Christmas tree. The triangles. Start from number 1, right? Yep. It's in the shape of the triangle. It's not like a triangle.
Pay attention. I'm not going to give you the answers.
Beauty is
Niagara Falls.
I've been there.
Guys, please don't shout stuff aloud so you can't hear the narration.
Daddy. Oh, that guy's
Jellyfish. No way.
That was bird. Oh, gross.
That's gross. Ew. Oh my God.
Oh. I got the first answer. No, no.
Number 2, coming up.
Loom. Out of which what?
Number 3.
Oh, yeah.
That doesn't look like a square.
Every what?
Number 6 and number 7.
Rabbit hunting.
Jesus Christ. Those things multiply like crazy.
Right?
That's where you got your numbers.
So all the plants you're seeing have the Fibonacci sequence embedded in them.
It was a seashell.
I told you guys.
I still thought it was turkey. Oh, it's an ottoman shell.
No, slave was. Have we got number 7 yet?
It's a ram horn. What number are we on? Snail. Snail, you were right.
What a snail?
What?
I told you, snail.
I'm still waiting for the turkey. Right.
I'm about to do a snake.
Next plank's coming up.
That's not a snake.
Oh.
That's a flower. I can see where you. You're back.
No, he's gone. Missed you, Zach.
No, he's been
I'm
there.
gonna do it in here.
That's fine.
The plug-in.
Oh, you guys are so cute.
It looks like Ryan's. Oh, you're a cute little baby, Ryan.
I was the fattest baby ever.
Really?
Oh, I got a 10.
That's cute.
That's my Fractal.
Did you say 10?
Freaking ugly. What's number 7? What?
Yeah, see, sorry, I just need to keep the shirt.
Did you forget number number 8.
Okay. Go. No. Got you.
Yeah, 8 and 9 are coming up.
Coming up soon.
That doesn't look like a triangle. How do you know?
Fractals are pattern.
Get 9.
These are congruent exactly the same shape.
Why is it?
Does anybody have lead? Now you got some in your arm.
5, 7, and 9.
I don't know. Sides.
Woo! Tie-dye. That's like something you'd look at when you're on acid.
Nope. They're running to the same shape.
We have fun number 10. If you want to do that.
And
Ew, what is that thing? Ew. It's scary. Let me
same shape.
What's that?
The pattern.
It measures time.
That's making me dizzy. I don't think so. What is that? Pattern of
This is 10 and 11.
Wait, where is it?
Why do people say that?
So, that's too long.
What's your golden?
Wait for it.
Dude.
Give me that.
Hey, I've been there.
What is embarrassing?
I just kind of
Why
got
is that funny? Oh.
You like the dinner? I like the dinner. I like the
What's his age?
I like the shape.
He's the age.
right now.
Me too. I think it was.
He's not.
Number 10 coming up. All right, guys, I'm already repeating this once.
Whoa, what happened? Did anybody walk me on? Oh, I see it. Either way, you're right. It's so funny.
They don't know it yet, it is.
What is it? Parthenon?
Wait, what was that picture called? The 15 chocolates. That is not the name of that. It's 15 chocolates. Yeah, but what is it called?
You should, okay, I'm going to rewind it one more time. You should be on 13. 12, 13.
Parthenon. Oh, it's not Parthenon?
Yes, the Parthenon, the Notre Dame, Giza. They're all based on the golden ratio.
Numbers Legion.
13's coming up. Okay, so how many people are musicians?
I used to play piano.
Okay, so when he says major 6, did you guys know that the major 6 is based on the Fibonacci sequence? The intervals of 3 to 5, 5 to 8, 8 to 13, if you count that out on your scales, on your notes, including the sharps and the flats, you're going to get what's called the major 6 combination. So the major 6 musical chord is based on the mathematical sequence that you guys experience called the Fibonacci sequence. That is what's called that's an Alex assessment. You can take it just for fun.
Too much blood for it. I don't know if my doctor will go. I don't know where it is. Go there.
Just the last blank.
I'm good. I know it.
I want to learn how to play that. I know how to play it. Whammy.
That's the Wendy for vibrato. Smiley face. Oh yeah.
You should have 1 through 14 done.
Wait, 14 was already.
Yep.
Yeah, you have to like this. Tell me what it's on.
When you're done, turn to the next page, please. Page 5. Flip to page 5, please. All right, students. For your sign-off today, we are going to do something right at the end of class, but for now, this is what's going to constitute your sign-off. On page 5, let me let you know, there is no right or wrong answers. Sierra, some people would, no right or wrong answers here, but I do want a complete thought. That means a complete sentence or two if needed. I would like your opinions. So these are subjective, responsive questions 1 through 4. That means they're your ideas. Do not write like you're trying to give me a specific answer. I want you to write what you're thinking. I want it in a complete sentence. When you're done, then bring it over for a sign-off. I'll give you a few minutes to do your study guide. At the 15, we're going to shift and do one last little activity right at the end of class. Where did it go? Oh, there it is. Three vocabulary words. The first word. Right here, I'd like you to write this word in the front where you have all these numbers here. What we have here is a repeating math computation. A repeating math computation. That's called an iteration. A repeating math computation. So on the front, when we took the two numbers added, then two numbers added, two numbers added, that's called an iteration. All right. Here, when you take an iteration and you make a visual picture of it, that's called a fractal. So this image is called a fractal. A fractal is a visualization of an iteration. You want to write this down? This might pop up on a test in another 10 days. Thank you, Mr. Fields. Appreciate that. Yes, sir. Fractal. A fractal is a visual representation of an iteration. We took that iteration and we made a picture of it. That's called a fractal. When you're writing this, I'd like you now to flip to page 6, please. Page 6. Yes. I have a line. Annalise was next. Okay. Under iteration, page 6. Write this. Repeating math equation. That's an iteration. A repeating math equation. A fractal is a visual of an iteration. A fractal is a visual of an iteration.
What'd you say? No, not you, Miss Wade.
Got it. I didn't assume. With that tone of voice, I hope not. I appreciate it. No, I got it.
I wasn't quite sure myself.
Self-similar. Yes, a repeating pattern of similar shapes. Either you're going to go large to small or small to large. A repeating pattern of similar shapes, something self-similar. So I'm going to give you an example of how an iteration and a fractal work together. Keep in mind what we're doing is math. It's pure 100% math. Okay, I'd like you to go to page 7. We're going to skip this section on page 6. Go straight to page 7, please. Look at the top here. All right, we're almost done. This is input, output. This is a very common way to express an iteration. Our function, you could have any number of functions here. Our function is going to be divide by 2 or times by 1/2, same thing. So if I take 1 and I times by 1/2, I get 1/2. Okay? So bring it up here. We have 1/2. And we times by 1/2 again, and we get 1/4. Bring 1/4 up. Times by 1/2 again. Up here. Times by 1/2. Yep. Get 1/16. Okay, so this right here is called an iteration. Okay, again, it's a series of math. Now we're going to make a fractal. So taking this, I'd like you to, after this we're going to pack up. I'm going to show you one last thing for fun, and we're going to be done. Okay, ready? We started with 1. Draw 1 segment, please. 1 segment.
1.
Yep, in the middle.
Why?
And our next number was 1/2. So we're going to take the 1 and we're going to split it in half. We're making a visual representation of the iteration. We're making a fractal. Okay? Now, our halves we're going to make into 4. So 1, 2, 3, 4. 1, 2, 3, 4.
Santa Claus.
Now, on one side, I'd like you to go to 1/8. So take each of the fourths, go 1, 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6, 7, 8. 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Now take one branch, and we're going to go 16. So it's going to be 8 and 8 on either side, just on one branch. We won't have time to do others. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. Just do 1. 1, 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6, 7, 8.
Oh yeah. Yeah.
Okay, just do the 1.
Now it looks pretty.
I told you, is it possible?
Is this a tree? Is this a pine tree?
Oh, absolutely. You can keep going on and on and on. That's the whole point of an iteration. Now, you guys, what does this look like?
A tree.
Frog.
Pine tree.
Porcupine.
Frog.
Turkey feather.
Porcupine.
Porcupine.
Oh, looks like a
Okay,
bird.
what I want you guys, the key thing,
It's a plane.
one simple concept, guys. Listen. Real simple. You guys instantly started trying to associate this something in the natural world. What you are looking at is 100% math.
I was right.
Okay?
Sure.
But it's obviously just used in the natural world. Pack up. I'm going to have a quick short video for you. Pack up. Is it funny? Not. It should be mind-blowing.
There's a pencil. Oh, that's Aaron.
Wow.
All right, guys. In this video, every image you see is a fractal, which means it's based on a mathematical pattern. Keep that in mind.
You know the next week snowflakes are exactly the same.
Those are actual snowflakes under a microscope. You know fractal style. And they're all
I got you. Oh, it's great. Oh.
Your blood vessels are fractal patterns.
No, please don't.
Happy Thanksgiving. Are you going to school tomorrow?
Yes, I am.
Okay, because I have a question.
Yes.
Why don't you put your calculator away that you keep throwing my food?
What's up?
Because I did not understand the Alex quiz
Okay.
this last week, so I was wondering if you could help me, but I just remember I have
Happily.
a meeting
Yes.
with Mr. Troche.
Yes.
So can I do it?